Good day. How are you doing today? So in this lesson, I'm going to show you how to differentiate using the rule. This is actually a very easy method of differentiation. So before we do that, let's suppose you are given a function y is equal to f of x. Therefore, the first derivative of that can be illustrated as f prime x. This f prime x means first derivative, or the gradient function. This can also be called the gradient function. Now, if you are also given the function of y in terms of x, the first derivative can be written as dy dx, which means the rate of change of y with respect to x, which means also differentiate y with respect to x. And this is the same language. So this means exactly the same thing. It just depends what you be given, either f of x or the function y. So if you are given function y, you do the dy dx. If you are given f of x, you just do f prime x, which means also the first derivative. Now, the rule of differentiation states that if y is equal to x to the power of n, therefore the derivative of this function dy dx will be equal to, so what you simply do, you bring down the power here and then you minus 1 on the power. So the dy dx will just be equal to n x n minus 1. And you understand more when you do some examples in the next section. Now, the other thing that you need to understand is that if you have got y is equal to a, let's say a is a constant like value 6, 3, or any other value that doesn't have a variable x, then the derivative of that dy dx will be equal to 0. So the derivative of any constant is equal to 0. So now let's get into some examples and explain this further. Now, in this example, we are asked to determine the first derivative when f of x is equal to x to the power 9. Now, remember, the first derivative of x is equal to nx to the power of n minus 1 if f of x is equal to x to the power n. So the first derivative is just bringing down x, then we minus 1 on the power n. So in this case, the answer will be first derivative of x will be equal to, we just bring down the 9 and then we minus 1 here. So that will be 9x to the power of 8. And that's your first derivative. Now moving on to the second example. In this example, we have got about 3 terms. 1, 2, 3. So we need also to determine the first derivative. Remember, if we have got a function of x is equal to x to the power n, then the first derivative, which is f prime x, is equal to, bring down n, x to the power n minus 1. That's exactly what we apply here. But in this case, we differentiate all the 3 terms separately. And this will result like f prime x will be equal to the first derivative here. We bring down the 7 and it multiplies with a 5. And we get 35 x to the power 6. Then plus we do the same thing here. We bring down the 2, multiplies by 5. Then we get 10 x to the power 1. Then the derivative of a constant, remember, it's 0. So therefore, the derivative of this function will be 3x to the power 6 plus 10x. Now, moving on to example number 3. In this case, we are asked to find dx of 3x to the power 4 minus 2x squared plus 5x cubed minus 1. This means exactly the same thing. It actually means find the first derivative of that. It means exactly the same thing. So then the first derivative of that will be, so we'll say dy dx will be equal to, in this case, we bring down the 4 here, multiplies with the 3, that becomes 12x to the power 3 minus 4x, then plus we bring down the 3 here, becomes 15x squared. And that's your derivative. Now moving on to the fourth example. Now in this example, one has to be careful because we have got a variable on the denominator. You don't want to differentiate when the variable is on the denominator. So the first thing that you do is just rewrite the whole thing and you try to split these fractions, like 7x over x cubed minus 4 over x cubed, then minus 2x to the power 6 over x cubed. Then we are not differentiating it. We need to bring these variables that add the denominator to the numerator. So we apply the laws of indices, and that becomes 7x times x to the power negative 3 minus 4x times to the power negative 3 minus 2x to the power 6 multiplied by x to the power negative 3. Now we simplify this further to become d of dx. Then here, remember, when you are multiplying the algebraic part with the same basis, we just add the powers. So this becomes 7x to the power negative 2 minus 4x to the power negative 3. Then here it's 6 plus negative 3, and that becomes negative 2x to the power 3. Now you can differentiate. Therefore, the derivative, which is dy dx, in this case will be equal to, you bring down negative 14x to the power negative 3, because we say negative 2 minus a 1, that's negative 3. Then minus, we bring down here, so that becomes a plus. So minus 3 times negative 4, that gives us a 12x to the power negative 3 minus 1. Remember, minus 1, that becomes negative 4. Then here again, the same thing, that will be negative 6x squared. And that's how you determine the first derivative here. Now moving on to example number 5. So in this example, what you don't want to do, you don't want to differentiate when the terms are in the brackets like this. So the first thing that you need to do, you need to expand that. And also the other thing, you do not want to differentiate when it's like a square root. So the first thing that we do, we open the brackets. Y is equal to square root of x times that. That becomes 2. Remember, square root of x times square root of x is just x. Then just becomes 2x. Then that times that becomes minus 5 root x. Then this times that becomes plus 6 root x. Then that times that becomes minus 15. Then this becomes y is equal to, remember in this case we've got like terms, minus 5 root x plus 6x, and that can become root of x. So then y is equal to 2x plus root of x minus 15. This can be further written as y is equal to 2x plus. So you do not want to differentiate when you have got a square root. Remember, the laws of indices say that the square root of x can be written as x to the power a half minus 15. Now you can find your dy dx. Remember, you can only write dy dx when you are differentiating. You don't write dy dx anywhere here, because that will be wrong. So then you differentiate that. That will be a 2 here, plus you bring down the half, then x to the power negative a half, because here we say a half minus a 1. Then derivative of a constant is 0. So that's how you find the derivative of this function. Now moving on to the last example. Find the derivative of y is equal to 1 over x squared, x to the power 7 plus 7. Now, remember now, the first thing that you want to do, you don't want to differentiate again when your variable is at the denominator. So the first thing, you want to bring it up. So y is equal to x to the power negative 7. Remember your laws of indices. Then plus a 7. Then you find your derivative, which is dy dx in this case will be equal to, you bring down the negative 7, that will be negative 7x. Then you minus 1 there, that will be a negative 8. Then plus a 0. So then that is your derivative. And that's how you do differentiating using the derivative rule. I hope that makes sense. Hope to see you again in the next lesson.